This is a proof of concept model of my continuously variable transmission, which I call the torque inducer. This is a CVT inasmuch as there are no gears to shift, but it is fundamentally different from the common CVTs in that its operation doesn't depend on friction, spark clutches, or ratchets. All components are in rolling contact, either gears or anti-friction bearings. Also, unlike all current transmissions on the market, it doesn't multiply engine torque, but generates torque from engine speed by means of inertial forces. There are many CVTs that have been patented, including some which use inertial forces to generate torque, but except for the hydrostatic ones, they all depend on friction, ratchets, or spark clutches. The torque inducer generates continuous torque without such devices. It consists of a gyroscopic mass mounted on this shaft by means of a constant velocity universal joint, two gearboxes, a prony brake, which is a frictional load the torque inducer is driving, and an output torque indicator marked in pound-inches. The output speed can be seen by observing the rotation of this gearbox housing. The prony brake is simply a disc connected to output, which is the housing of this gearbox, equipped with an adjustable friction device, which is manually adjusted to control transmission load. The input speed is driven by an electric motor through this pulley, which is controlled manually, and the output speed by adjusting the friction load on a prony brake. The prony brake originated in the steam engine days, but it is particularly suitable here as it can measure torque at any output speed, including zero. Torque is generated by gyro nutation, which is a variation of gyro tilt angle, and is driven by this yoke connected to this epicyclic gearbox, which also drives the gyro spin at motor input speed. Gyro nutation along the two disc axes is achieved by driving the line of nodes of the gyro disc. The components of this model are approximately full size for a medium-sized car. The model would be more compact if the discrete components were integrated into a single housing. I will start the demonstration of the torque inducer by running with an input speed of 350 RPM, which is slow enough to see all the action without overloading it. The prony brake disc is now locked, and the indicated torque is about 30 pound-inches. In this model, the tilt angle of the gyro is limited to about 20 degrees by what I called fuzzy drive inside the gyro, which converts the gyroscopic moment to torque on this shaft. I will now increase the input speed to 450 RPM and vary the frictional load on the prony brake to show the smooth variation of output speed to accommodate the load. Note that applying torque to a stalled load demonstrates the efficiency of the torque inducer. No existing transmission can deliver torque to a stalled load for very long without overheating. The input power needed to generate this torque is fed back to input and recirculated. Since all the driving components in a torque inducer are in rolling contact, either gears or bearings, it has no means of dissipating power except in a prony brake. The common hydraulic torque converter is capable of driving a stalled load, but the power used to do this is dissipated within the unit as heat, and it has to be cooled. The unique features of a torque inducer are the fact that power used to generate torque is either used to drive a load or is fed back to input. A drive, which I call fuzzy drive, which converts the gyroscopic moment to unidirectional torque continuously, and driving the line of nodes to achieve nutation along both transverse axes of the gyro. This model demonstrates that unidirectional torque can be generated inertially and with a high efficiency inherent to mechanical systems. The torque output is small, but torque is generated as a function of speed squared, and in this demonstration the gyro was driven as less than normal engine idle speed. And keep in mind that this is a proof of concept model, not a prototype. It was simply constructed with as little investment in time and effort as possible, and some potentially torque enhancing features have been left out to keep the model simple. I also have a prototype layout which is patent pending, and I'm seeking a manufacturer to help me bring the torque inducer to market.